Welcome to the Physical Science Reviews. My name is Caleb Price, and I'm going to be taking you through several of the chapters throughout these units. So the whole purpose of physical science is to give you a brief overview into the mathematical and physical sciences without getting too much bogged down into the math. So to start things off, we're going to start off with things like the scientific method, different arrays of forces, and where we come to know scientific knowledge. So let's start this off with our first topic, the 4 shared sources of knowledge. If you've read your textbook, you've already got a step ahead of me. So this first one is authority. Authority just means that you have had somebody in a position of influence, like a teacher, a friend, a family member, in a religious context, God, tell you that something is true. From that, you know that something is true, and you can have faith in that it is true. Think about it. Everything you've ever learned in school was learned from an authority context. Let's go ahead and move down here into sensory data. Sensory data is using your 5 senses to be able to figure something out. You're able to sense pain, you're able to sense touch, you're able to sense heat. All of these things you know that exist because of your sensory data. Our third one is intuition. Intuition is just knowing something to be correct or true. Your emotions fall into this category. Your belief or existence of God falls into this category. Something that you have a hunch about. That is intuition, something that you just know to be true. Our fourth thing is reason, our 4th shared source of knowledge. Reason is using your previous experience to form assumptions, biases, or claims that you can then use into a forward situation. An example would be mathematics. You have learned previously addition, subtraction, division, multiplication, but now you're able to take your reason and establish a set of contexts using mathematical rules to figure out a future problem. So I can give you something you've never seen before, and you're able to come to a truth, to come to a knowledge of what that is. And so some possible applications of these 4 things would be to apply it to a different situation. Try to find out, where are things in my life that I've learned from an authority context? What are things I know because of intuition? What are things I know because of sensory data? What are things I know because of reason? And you'll be well on your way to establishing where your own assumptions and biases and the things you hold to be knowledge, to be true, where those actually come from. So now let's go through how scientists are able to figure out what is actually true by going through the 6 self-evident truths. This is a basis of where all knowledge and scientific reasoning comes from. So the first, and also the most subtle, is the concept of existence. Philosophers have been trying to go over this for millennia, trying to figure out what exactly it means to exist, what it means to be something. And so scientists can all agree that there is something that exists. This is a self-evident truth. Our consciousness inside of our brain exists. From there we move on to causality. Cause and effect relationships. So if you can apply this to a variety of situations. For example, if somebody punches me, I am probably going to get a bruise. That is causality. That is knowing that one thing leads to an effect of something else. Our third thing would be position symmetry. All scientific experiments are going to be based off of these last few principles. Position symmetry just says that if I perform an experiment here, if you perform the exact same experiment somewhere else, you would get the exact same answer. This is saying that the laws of nature are the same in every reference frame. They are the same whether you live in Alaska or you live in Kentucky. Your results might be different based off of other factors, but the laws of nature never change if you're here or you're on the moon. Related to that is the concept of time symmetry. Time symmetry just tells you that if you replicate an experiment, your results will be the exact same if you do it now or you do it in 10 years. The laws of nature do not change with time. So we can confidently assume that 10,000 years ago, gravity was still here on Earth. Gravity still acted on things like the dinosaurs or early mammals. And the position and time symmetry allow us to be able to know that. The principle of non-contradiction is our second to last one. Non-contradiction just means that if you have 2 opposing viewpoints that describe the same thing, one of them has to be wrong. The example used in the book are the different models that the way celestial things like stars and the planets move. Is the Earth the center of that, or is the sun the center of the universe? You know through the principle of non-contradiction that you can't have 2 theories to explain the same thing and have one of them be correct. One is correct and the other is not, and it's up to scientists or you to be able to figure that out. Our last principle is Occam's razor. Running out of board down here. Occam's razor just says that if you have competing theories about something, usually the simplest explanation is usually the correct one. The one that encompasses everything but is the most simple in explaining it. Now, I've used very big generalities to be able to describe these different principles, but in your own life, try to figure out, have you ever done position symmetry before? Have you ever done time symmetry before? When you were being raised, did you know that if you stole something, you were going to be punished for it probably? And you knew that in the future, if you tried to do the same thing, it probably wasn't going to fly either. These other principles, Occam's razor and the principle of non-contradiction, are usually the ones that students struggle with. So I'm going to go over them in a little bit greater detail for the next minute or so. The principle of non-contradiction can be used in your life to explain, let's say in emotions. Somebody gave you a dirty look. Either they don't like you, or maybe they were having a bad day. It's probably not both, so it's probably one or the other. Occam's razor you can use to explain something simple. Gravity causes objects to be held towards the Earth. Or maybe there's a special magnetic field somewhere in the universe that causes everything to be held towards the Earth. It's usually the simplest example, which in this case means gravity. The chapter also outlines the scientific method. The scientific method is a system where we use laws, theories, and hypotheses to try to understand the world around us. But for this class, you've already learned all of this. We're going to take all of this and combine it into something called models. Models are a man-made representation of what the universe acts like. Whenever you learn about the models of the atom, the models of human behavior, the models of cellular respiration, whatever it is a man-made human explanation for what we observe in nature. So that's all you got to know about the scientific method for the purposes of this class. Now finally, we're going to talk about the 4 fundamental forces, and that will be the end of chapter 1. The 4 fundamental forces are describing what causes things to happen in the universe, here on Earth, at an atomic level, or up in the stars. And so we're going to start from the smallest and go to the biggest. The smallest force is the strong nuclear force. The strong nuclear force acts on the protons and the neutrons inside the nucleus of an atom. Its influence does not extend past the nucleus. The nuclear strong force is not felt at all by the electrons that are orbiting the nucleus, only within the nucleus itself. Secondarily is the weak nuclear force. If you ask anybody, except for a Nobel laureate, what the weak nuclear force is, they'll just mumble and say, it's not important. For this class, that's exactly what we're going to say. The weak nuclear force causes stuff that is not important for this class, although it is a fundamental interaction of nature, a fundamental force. Third, the electromagnetic interaction. The electromagnetic interaction is the influence and things that happen between positives and negatives. So this covers everything in your daily life. Positives and negatives govern how you don't fall through the floor. They govern your interactions when you hit something. They govern everything that happens inside of your body. Positives and negatives. So this force, this interaction, is applicable from the size of atoms with the neutrons, the protons, and the electrons all interacting together, all the way up to the size of continents. Because once you get up to the size of continents, all that matters is gravity. We're not really interested about what happens on the sun due to the electromagnetic interaction. All that we feel from the sun here on Earth is due to gravity. Gravity is the interaction that governs all of the celestial orbits, all of the stars. Everything bigger than about a continent or a mountain is governed by the force of gravity. So that's chapter 1. Thank you for watching.